My name is Karim Dada. I'm from Arab. I'm a mechanical engineer. A few years ago, I started working on something called design by code. Basically, looking at all my tasks and workflows in terms of a mechanical engineer, taking them from stage 1, 2 to 3, and trying to code them. And that part is basically trying to automate and optimize design. For this specific presentation, I am focusing on digital versus simulation. How can we use digital technology or coding basically to automate our simulations and go through a lot of more options that we actually do in the situation. So our few principles. This is basically to automate the building physics simulation workflows. Once we got that, we were able to better optimize the building performance, and because we're working in code and scripts, we are able to generate structured data. That is actually a key aspect of this workflow, because we can generate a lot of data for future benchmarking against different projects and different scenarios. What you see at the bottom is basically me trying to automate stage 1, 2 to 3 from everything from building physics to mechanical selection, electrical, and public health. So this is a really big workflow. But for this presentation in specific, I'm only focusing on a very simple problem just to show you the benefits of going digital. So I took a simple box, really, nothing much to it. I'm looking at passive design and mostly looking at the facade analysis of this. Just to show you the number of options that can come up with just varying a few variables in different ranges. So we took the facade box and we started looking at the external shading, varying the depth of the shade, the angle of the shade, number of shades, distance between the shades. Also looking at percentage glazing, U values, G values, Y values, you name it. So we had hundreds of options that we can come up with just by looking at a very simple box. We did this using scripts in Grasshopper and Ladybug, Python, C#, and so on. I'm not going to go through that. But the end result is it went through 576 options in 2 hours. Okay, this is a very simple. I'm showing a very simple geometry. The power of it, it goes through so many options in so much more efficient time, and we look at the multidisciplinary design and come up with all these options and structured data automatically uploaded online to a platform where you can filter through all the results within seconds. So at the top here, you'll see we just looked at, I don't think it's really visible, on the right, where you follow lines, you get all the metrics that you're looking at, and you say, I want my cooling load to be this, my heating load, and my daylighting, and so on. So all the metrics that you measured, you should filter through them within seconds. You come up and go through all the options and shows you the only 4 options that actually fit your description, your filter. I wanted to show up the tool live. I couldn't do so I did the normal thing we always do, a screenshot and put it on presentation. I was showing the architect baseline on the left, and then on the right, this is just isolating one of the variables and looking at the angle of the shade and how much difference it can make to the design. Everything from daylighting, cooling, heating, lighting, total energy, solar gains come up with this. As well, it sizes your terminal units and visualize them on the drawings. On the left side, on the architectural baseline, you also see it ray traces the sun rays and see the reflection through the shades back into the space to increase the. Next slide is, this is us taking the architect through the options. They wanted 100% glazing, and we were trying to show them that no matter what we did, we could never pass the compliance. And you can see that at the bottom of the page. So that was varying with looking at all the variables, all the different options. We could not pass the quartile 30%, over quartile by 30%. Future integration, we're looking at the embodied versus operational carbon. Look at the facade, embodied carbon on the facade, lighting, perimeter terminals, and natural ventilation, and also looking at that against operational carbon. We look at the total carbon at the end of the simulation. That's it.
Well done, thank you.
Hi there, Ben Abel. Do you think this is something that can be easily automated for everybody in the industry, or does this require specific skills to have this sort of heavy boost?
I cannot hear you, sir.
Yeah, sorry, is that better?
Yep.
So shout it.
Everyone can hear.
Everyone can hear it. What skills do you think, is this something that can be used by everybody in this industry at the moment, or do you feel that you need specific skills to be able to do these extreme levels of integration?
Are you saying that is this something anyone in this who can use?
Yeah. Is it very difficult to do this sort of stuff, or do you find...
No. It's so we're using graphical programming, which is basically through Rhino and Blossom, but it kind of simplifies the whole coding aspect of it. Once we do need to add in something more customized, we have coders in-house to develop these into components. It becomes a modular code. It's literally like Lego blocks where you just drop into your platform and just connect inputs to outputs. The script itself is done in-house. It's a combination of different tools, kind of like the previous presentation that we showed. Yeah.
Great. Is that okay? Thank you. This is the interesting. This is the interesting bit now. So the next ones are Griffin Consultants, who at the moment are in Dubai, lovely Dubai, good for them. And so they have sent a video presentation, and I've been talking to them by WhatsApp. I wasn't just texting anyone, don't worry. So I'm going to play this video, 5 minutes, and we'll get them on the call. Let's see if this works for the live question. Okay? So this is the one with the audio from the slides, yeah? Thank you.